In this video, we are going to understand the concept of time value of money. Suppose Mr. A puts 5,000 rupees in his bank for 3 years, and the bank gives an interest at the rate of 9% per annum. And after 3 years, he is going to get back 6,475. So the present value of 5,000 will have a future value of 6,475. So here the present value, which can be written as PV, or P of 0, which means P after 0 years, or the present value itself, or the principal is rupees 5,000, and the future value, which can be written as FV, or FV after 3 years, the future value after 3 years, or the amount received after 3 years, is 6,475, and the number of years is 3, and the rate of interest will be written as small I, which is 9%, which can be written as 9 upon 100, or in decimal we can rewrite it as 0.09. So in the school we have already studied the formula for simple interest, which is simple interest I is equal to PNR upon 100. So we can rewrite the same formula as SI, which is simple interest. Instead of principal, we are writing present value. Instead of R upon 100, we are writing a small I. And instead of a capital N, we are writing a small n. So present value into small I into N. Similarly, we know that amount is equal to principal plus interest. So amount can be replaced by future value, FV, is equal to present value, principal, plus the interest, but the interest itself is PV into I into N. So we can write PV into I into N, or alternatively we can write SI over here. But for compound interest, we first find the amount, where amount is principal into 1 plus R upon 100, the whole raised to N. So over here, the amount is replaced by FV, principal is replaced by present value, 1 plus R upon 100 is replaced by I, and the capital N is replaced by small n. And then the compound interest is this amount minus the principal. So the compound interest would be the future value, which is the amount, minus the present value. Let's take an example. A fixed deposit receipt has a maturity value of 1,30,000. Means we are going to get 1,30,000 in the future. What is the amount at which the fixed deposit receipt has been initially purchased? Means what is the amount as of today, the present value? If the simple interest, so we are going to use the simple interest formula, the rate is 10% per year and the maturity is after 3 years. So we have been given that the future value is 1,30,000. The rate of interest is 10% per annum, or 0.10, or simply written as 0.1. The number of years is 3 years, and the present value we need to determine. So let us say the present value is X. So the formula for the future value is principal plus interest, where interest is P and R upon 100, So this is the formula to find the future value with respect to simple interest. Now we are going to substitute. So we are writing 1,30,000 underneath FV. We are writing X underneath PV. We are writing X underneath PV. We are writing 0.1 and 3. We can take X common. So we'll get 1 plus, and 0.1 into 3 is 0.3. 1 plus 0.3 is 1.3, which is dividing over here to get 1,30,000 divided by 1.3 is equal to X, which gives us the value of 1 lakh rupees, which means 1 lakh as of today will be 1,30,000 after 3 years. At what rate percent will rupees 26,435 amount to rupees 31,722 in 4 years? And we have been told to use the formula for simple interest, because if we are not told anything, we have to use the formula for the compound interest. So here the present value is 26,435. We do not know what is the rate of interest. The number of years is 4. and the future value is 31,722. We use the same formula. We substitute in the numbers. We take this 26,435 on that side, and we multiply the 26,435 I and 4 on this side. So we get 31,722 minus 26,435 is equal to 1,05,740 multiplied by I. We subtract these two to get 5287, and the right hand side remains as it is. Finally, we divide this number to get 5%. Ascertain the compound value and compound interest of an amount of rupees 75,000 at 8% per annum compounded semi-annually for 5 years. So over here we know the present value is 75,000. But this is 8% per annum compounded semi-annually. Means after 6 years we are going to calculate the interest. And then after 6 months. And after another 6 months we are going to calculate the interest over the interest also. For 5 years. So we are going to do this compounding for 10 years. So the rate of interest will not be taken as 8% but half of the 8%, because compounding is done 2 times a year. And the number of times it has been compounded is not 5 years but 5 twos are 10 times. And we need to find what is the amount, what is the future value, and also the components. So we take the formula FV is equal to PV into 1 plus I the whole raised to n, and we substitute in the numbers. 0.08 divided by 2 is 0.04, and 5 twos is 10. 0.04 plus 1 is 1.04, and 1.04 raised to 10 is 1.480244, multiplied by 75,000 gives us 111,018. And in order to find the component first, we use the future value minus the present value. So 1,11,018 minus 75,000 gives us 36,018 rupees. Rupees 2,000 is invested at annual rate of interest of 10%. What is the amount after 2 years if the compounding is done first time annually, or if done semi-annually or 2 times a year, or monthly 12 times a year? So there are 3 sums in this sum. So we have been told that the present value is 2,000. Rate of interest is 10%, so 0.1. Number of years is 2. Future value not known. So first, when it is done annually, we can simply use the formula and substitute in the numbers to get the answer. But when we are going to do it semi-annually, remember this 2 years will become 4 times, because the compounding is done 2 times a year, and this 10% will become 5%. So it is 10% per year and 5% per 6 months. So we use this modified form. FV is equal to PV into 1 plus I upon M, where M is the number of times the compounding is done. So in semi-annually, the compounding is done 2 times a year. So the value of M over here is 2. Raised to n multiplied by m. So just raised to n is now followed by n multiplied by m, and over here we divided m. So we substitute the numbers. PV is 2000, 1 plus as it is, 0.1 the whole upon 2 in raised to 2 into 2. 0.1 upon 2 is 0.05, plus 1 is 1.05, 2 2 is 4. If 1.05 is raised to 4, we get this number, but multiplied by 2000 gives us 2,431 and 1 paisa. So if you see, this number is slightly bigger than this number, because over here we are getting the interest only after the end of the year. Over here we are getting the interest after 6 months, and we are getting the interest over on that interest also for another 6 months. So we're getting a slightly bigger number. So when this is done monthly, this value of m will become 12. So we first write that modified formula and we write a 12 instead of 2. So 0.1 the whole upon 12 plus 1 the whole raised to 24 is being provided directly over here. And when multiplied by 2000 we get 2440 rupees and 78 paisa, rounded off to the nearest decimal. And you can see this number when compounding monthly is bigger than when it is done twice a year, which is bigger than when it is only done once a year. An investor invests rupees 1000 right now, that is at the beginning of the year, and he's going to invest 2000 at the beginning of year 2, means after 1 year from now, and rupees 3000 at the beginning of year 3, means after 2 years from now. How much will these flows accumulate at the end of year 3? So it simply means that 1000 is being invested for all 3 years, 2000 is being invested for 2 years, while 3000 is only going to be invested for 1 year. And the rate of interest is 12% per annum for all the 3 times. So the present value first time is 1000, the rate of interest is 12%. Number of years 3, because 1000 is going to be invested for 3 years. We need to find what is the future value. We write in the formula, put in the numbers, multiply them to get the answer as 1404.928. Second time, the present value is 2000. The rate of interest is again 12%. Number of years this time is 2 because it is kept for 2 years. The future value is to be determined. So we again write down the formula, plug in these numbers to calculate the answer. And the third time, the present value is 3000, but it is only to be kept for 1 year, and we need to find what is the future value. Again, just substitute in the numbers to get the answer as 3360. So if we add up all these 3 numbers, we get 7273.73. Now let us discuss what is the effective rate of interest. Suppose a bank pays or calculates interest monthly or quarterly or after every 6 months. The effective rate of interest will be much more if done every month rather than if done every quarterly or after every 6 months. That's because the interest starts accumulating after the end of the first month itself, and then after every month, and then accumulated interest also earns another interest. So the effective rate of interest will be much more than if it is just mentioned as a per annum. The formula for the effective rate of interest is EI is equal to 1 plus I upon m the whole raised to m minus 1. We did this modified formula a little time ago, so this is just an extension to it, but we subtract a 1 in the end. Let's understand this with the help of an example. Find the effective rate of interest if the nominal rate of interest is 12% and is quarterly compounded, means it is compounded 4 times a year. So the rate of interest is 12%. Compounding is done after every 3 months or 4 times a year. So we plug in the numbers in the formula and we get this answer. So the m is 4 over here, we had an m over here. 1 plus 0.03 is 1.03. When raised to 4 gives us 1.12550. And finally we subtract the 1 to get 0.12550, which can be rounded off to 12.6%. Determine the present value of rupees 78,67,597 receivable, means this is the future value, at the end of 4th year at an effective rate of interest of 12% per annum. So we have been told that future value is 78,67,597. Number of years is 4. The rate of interest is 12%. And we need to find what is the present value. We can use the same old formula. FV is equal to PV into 1 plus I the whole raised to n. Plug in the numbers, whatever you know, please substitute. We write the PV as it is. We add 1 plus 0.12 to get 1.12. 1.12 the whole raised to 4 is divided over here to get 1.573519. And when 78 lakh is divided by this number, we get approximately, rounded off to the nearest decimal place, to 50 lakh rupees, which means 50 lakh, if invested now, will give us 78 lakh after 4 years. But there is another way. Suppose if you want to find the same answer using the table number 2 is useful to determine the present value. And if you intersect 12%, which is mentioned over here, and 4 years, so n is equal to 4, you'll get a factor of 0.635518. And then you need to learn this formula. Present value is equal to future value into present value factor, which means the present value is equal to future value of 78,67,597 multiplied by this particular number, 0.635518. Just multiply the number and you get 50 lakh rupees.